and I am an associate professor at Vytautas Magnus University in Lithuania. Before starting this workshop presentation, I would like to thank you, the organizers, webQDA team, and specifically Professor Antonio Pedro Costa and Sonia Mendes, who inspired me to do this presentation. So today I will talk about automatic content analysis of internet and specifically of social media text. I show some examples, provide a review of methods and tools for data collection and the qualitative analysis. My presentation is based on the scoping review of scholar articles and specific software. My research is interdisciplinary and cover qualitative research methodology and computer science techniques, but I try not to go deeper into technological or coding details. So let me start. I would like to say some words about internet and about the internet data. So we all know that internet and interactive media technologies and applications are the reality of our days. Every minute we stick with this. These technologies and these data span interpersonal, organizational, mass levels of communication. Interactive media are rapidly replacing traditional media and modes of communication such as newspapers, magazines, school television, traditional phone calls, all that type of text. Facebook has become a leading interactive media content generator. Interactive social media dramatically affects our life globally. In some of my qualitative research examples and definitions, I will rely on the content analysis guidebook that you see in this slide. This is second edition, published 2017, and my own studies. Why I talk so much about the changing world, about the internet data? In order to analyze contemporary internet and interactive media content, it's important to understand that interactive media data, interactive media users' behavior, that these data are more than just receiving some text or consuming some text. Now users, our research participants, have an active role in adapting, altering, producing content. The data that a researcher needs to collect and later on work with this data. Indeed, content, the data for the qualitative study, had never been so rapidly available. It is seen that data is everywhere, but how to collect the data? So the internet contains a huge amount of information, and not just a printed content, but of multimedia format. So format changing, audio, visual material, animated material, and all this our data. In addition to traditional media content, such as books and videos, internet books, video online, internet contains interactive message data. Interactive content appears in ways that make its analysis and even capturing difficult. Traditional media content came in fixed forms, such as newspaper page that is frozen or fixed, the television episode, motion picture, but that's, if we see it one more time, it would be the same data. But interactive data that is in media, it's less tangible, changing, it's always moving, it's always changing. Web pages and other interactive content may also be updated moment by moment by creators, by our research participants. So we need to think that our data could be, next time it would be not the same data. And we need to capture that moment, but next moment maybe the data will be something additional or even different data. So how to work with this? Web 2.0 portals are changing or evolving. Sometimes that process is more rapid when researcher can adjust to it. So this is data challenges. traditionally, while doing content analysis, working with interview data, working with focus group transcribes, documents, written text, other information, researcher works with source and message content. While studying internet text, researcher deals with interactive media content. Now, content analysts should understand that data could be user-generated. It's user-generated content. It could be user-selected content, including user-curated content and interactive media output. All these new content forms, let's call them forms, and the difference between them are necessary to understand why developing content analysis of internet. All these forms challenge our traditional understanding of source and message content. So this is something different. The content is changing. Let me shortly explain all these forms of content creation. The first time, user-generated content. User-generated content is often considered like synonymous with Web 2.0. It refers to content created and provided by users through easy to use or frequently corporate owned tools. Examples of such type of content include Facebook profiles, Instagram photos and videos, Snapchat stories, emails, microblogging using Twitter, and similar data. So this is the data that user generates, the content that user generates. The second type, user-selected content. So this type of content refers to existing media products, social media products posted and shared online, such as when someone uploads, for example, a clip from TV show on YouTube or video on YouTube. Such type of internet content is reflective on individual message choices rather than message content generation. So our research participants or users, they are like actors. So they create the content and they select the content that they would like to show to us. They could show one content to one target group and another content to another target group. So when we think about the content, how we extract the content or how we grab the content, so that makes a difference. A particular type of content is user-curated content. This is different from user-selected content. The content that is selected based on the user's enjoyment and reposted for others without much thinking, without much thought. Curated content is selected and aggregated for the express purpose of meeting the needs of the audience. So the content is created for the audience. If this first type of the content user selected, I select the content that I like myself. For example, me as a scholar, I look through some articles, so I select the articles that I like. Okay, so and user curated content. So I show, I produce, I propose the content to other people, and this content is curated by me. So I show some content to one group of people, another content to another group of people. The example of such type of content could be Flickr or Pinterest photos or pictures or some information posted on these portals. Okay, so I post showing only some type of content or not all of this content. And the third type of content, interactive media output, refers to content created as media consumers navigate or use interactive media. Example could be how player interacts with video game. So this is a content that appears in video game. But we will not talk more about that type of content because to grab or to extract such type of content, we require more advanced capturing methods or active capturing techniques using programming languages such as R or Python or similar techniques, and this is more complicated. If you don't know coding, you personally, so that's easier to work together in a group with programmers if you want to extract such type of content. Analysis of internet text. So content analysis could be applied to such data as social media data, and we all would like to do that. So many scientists who use content analysis techniques manually read and analyze text. And this is very good. That's the most popular technique, and that works very well. But what to do if you have a lot of data, or if you have not so much time, or some other reasons? So automated content analysis could be used to save scholars time, to provide a wide range of tools to measure some quantities that the researcher could be interested in. I would like to stress again that automatic content analysis could be a solution. Although these methods never replace carefully and close, slow manual reading and analyzing, even online text. But today we are talking about automatic content analysis. So these methods exist, they are used, and people work manually and also with using technologies. Computer programs could be applied at two phases of content analysis. Firstly, for storing, analyzing, reporting research data. And secondly, for automatic screening of text, identifying and coding some specific words, phrases, categories, and so on. Automatic content analysis could be understandable as a six-step algorithmical solution. So, step one, text segmentation. For example, identification of some citing, other fields of each text in the corpus, in all the text that we do an analysis, that we analyze. Step two, similarity computation. In this step, the similarities between each pair of topics or clusters. So now we classify our text to clusters based on some common objects or features, such as keywords or citations or citings. And this is calculated. Step three, multi-stage clustering. So like advanced clustering. During this step, similar clusters that in similarity computations, we start to develop clusters. So similar clusters could be recursively grouped into large collections based on the above similarities until the number of reasonable and manageable generalized topics emerge from the collection. So in this step, we try to develop topics. So the topics emerge or are constructed from the text. Step four, cluster labeling. Cluster labeling means generation of cluster descriptors for easy of cluster interpretation. Just think that this is algorithmical solution. So this is an algorithm for the computer. Yeah, so now we have clusters and cluster descriptors or cluster names, something similar to cluster names. Step five, facet analysis. In facet or categories analysis step, cross-tabulation of topics with other facet data, such as citings, or other word noting events is done. So we analyze facets. And final step, or step 6, is visualization. Now we visualize a topic map. Such map could be created based on multidimensional scaling technique for revealing the relations among the directed topics. So now we have topic clusters, topics, and how we are related or how we are linked. So this is a visualization or mapping the results of findings. Recently, together with my colleagues, we did a scoping review research on automatic content analysis. I will present the results of this research. Our study has shown that social researchers who are automatic content analysts face these challenges. The first one, how to identify social media text for the automatic content analysis. How to find the text and from the different text pools or from a variety of different online information. How to find social media text that would be useful for my analysis. How to scrape, how to collect, and how to extract these texts. When we have a text, how to pre-process text for the analysis. The fourth step, how to analyze, this again a challenge, and how to research specific language. I'll go through all these questions and try shortly to explain how it's possible to do this. But before automatic content analysis, we'll need to prepare the data. To prepare internet data for automatic content analysis. So preparation consists of 2 steps: extracting data from social media networks or virtual communication channels. You could find the name data mining. So this is the same, extracting or mining the data. And the second one, pre-processing and setting research objectives. In a pre-processing phase, the researcher prepares raw data. When we extract data, it could be data with some additional text that is not necessary for our research. So we'll need to pre-process or to make that data, like poor data, for the future processing. Data mining. If you Google for text extraction, you will find that data mining techniques could be used, text retrieval techniques could be used, data extraction, scraping, web harvesting. Actually, that for the social researcher, that means the same. So this is the methods of internet or online data extraction. What does it mean, data mining? Data mining is a way to collect data from web automatically and not intervening with our research participants, with these people whom we observe, or with the data that we collect. There are some advantages of such data collection. There are some minuses or disadvantages. Advantages are that method of collecting internet data and studying social behavior, we don't see the people and we don't affect these people whom we research, our research participants. We could argue, is it good, is it not good? It depends, but the method allows us. Social researcher or coder are not actively intervening in the data collection process. The algorithm is doing everything for us. So we just start with data mining and go to drink some coffee, and later on we return back and the data is correct. So it not goes so easy, but it could be like that. So some scholars say that harvested data or mine data is more objective and reliable than the data obtained from surveys or experiments or even interviews. Why we say so? Because it's possible to mine a huge amount of data. So we're not talking about big data, but we could extract more data from internet when we could find data from surveys using some other technique. But the main disadvantage is that we don't know about these research participants whose data we are collecting. So we in many cases, we don't know demographic characteristics, we don't know psychological characteristics, and we don't see these people. So we don't see people faces. That also is the data for social research. And one more thing that we need to have in mind, so that's data protection law. So how much data we could officially collect, because some data is protected, some data is not available, and people are protected, our research participants are protected. So we'll need to talk with them and to ask them to allow to collect their data in many cases. But if we work with, for example, news portals or some media portals where data are available, so that method is very good and that's working. Types of data for mining or harvesting. There are 3 different types of data. And here you could see the examples of that data. So the content data. The examples of content data could be news portals or discussion forums on news portals, user profile data for social networks, news article data in various formats, in multimedia format, photos, videos, audio data, multimedia text, and so on. So this is a content data. But data could be structured, unstructured. Again, format helps us to collect the data quickly, or if it's unstructured data, so that's more complicated. Behavior data, the second type of data. So such type of data could be comments on posts, or comments on blogs and videos, or comments in news portals. From that data, we could see people behavior. Reviews, for example, if it's some advertisements, so reviews for products, music videos, many other daily behavior, how people behave, how we talk online, and how later on they record their daily experiences. So these behavior data in most cases have timestamp. So because that behavioral data is changes, and the time when the person behaves this or that, so that's important for us. Again, data could be structured and unstructured. And the third type of data, so this is network data. It could be behavior, could be user entity behavior. So how our research participant, let's call them user, how they behave with things, with entities. Second type, user community behavior, how our research participants behaves with community. And user behavior. So in this type, when we collect data, so we collect data from, for example, private messages, such as WhatsApp messages, or Facebook Messenger text, and so on. So this is user behavior. And as I already said, that network data, But if we have a network data, some other methods are applied, and it's easier to apply, for example, social network analysis on network structured data than automatic content analysis. So now we know about the data, how to extract, how to data mine, how to do web scraping. Here you see an example of one of these software, a free web scraper called ParseHub. But if you Google, you could find different web scrapers. Some of them are free of charge, some of them you'll need to pay for the licenses, but you could extract data quickly using these web scrapers. And if you do, if you need to do that web scraping, so just Google or make a search with the keyword web scraper. Okay, so we talked the procedure before automated content analysis. We collect the data. So how to do the automated content analysis when we have the data? So we could, in many cases, two different research objectives for automatic content analysis exist or are set. First, we could classify pre-processed data to known and unknown categories. And second, to scale the data to so-called Vorskos, dimensional information, and Vorskos, positional information, with supervised or unsupervised learning techniques. So these are mathematical calculation methods. What does it mean? Vorskos and Vorskos. Vorskos is widely used procedure to extract scores for new text paths or segments on the basis of scores for some text, it could be words, derived from documents with known scores, word scores. And word fishes, this is a statistical algorithm that determines the position of the text path or text segment in a document, word fishes. If the categories or classification are known, dictionary-based or supervised methods could be applicable. Using unsupervised methods, it is possible to make an individual classification of data or measure proportions classifying text to individual data or some groups or ensembles. If the categories are not known, unknown, fully automated or computer-assisted clustering could be could give us better probability or could be a better solution. So word scores and word fishes. Here you could see an example. The basic idea of word scores is to compare frequency distributions of words of documents with known positions with the frequency distribution of text whose positions is unknown. Known positions are derived by using experts. Experts are social scientists or the researcher. So expert judgments on specific dimensions. In this slide, you see an example of a Vorskos model that is used to identify language that separates two groups of internet text creators. These two groups of internet text creators were climate change skeptics and climate activists. You could see that in red color are skeptics in left part of the screen, and on the right are activists. They are in green. So if we need to make a distinction between these skeptics and activists, we could use that word score method. Wordfish is an unsupervised scaling technique, as you could see from the previous slides. Unsupervised techniques are usually described as a posteriori techniques. Science researchers do not have prior knowledge about the dimensions will be observed in the document. So in that case, unsupervised method put more emphasis on the in-depth interpretation of the dimensions. Here is another example, and in left, you could see the distributions of political parties that were collected using that Wordfish algorithm. And on right panel are positions of each party and the text these parties are uploaded online or provided online. So mathematical algorithms helps in this. As you could see, a lot of different methods and tools for automatic content analysis exist. In this table, we try to collect and to put into table the most popular packages and programming languages that could be used for automatic content analysis. In this table, specific qualitative research software such as webQDA or MaxQDA or similar, you will not find such software, so it's excluded. Scholars, our research showed that scholars mostly use R language for Vorskos and Vorskos calculation, R, Python, MATLAB with these mathematical packages for machine learning and for computational statistics. This is a continuation of the table that you saw in previous slide. In this slide, you'll see that using some lexical, semantic software, statistical tools, qualitative information could be extracted, identifying some key attributes, factors, themes, and each method has some specific strengths and weaknesses. And everything depends on the goal that you would like to reach using automated content analysis. Choosing the right approach, technological approach, is important in order to maximize efficiency and the relevancy of insights. The choice of method is dependent on the length of text characters, on how huge your text is. And the second thing is the language of internet text. In this provided example, or in this table, there are, it's uploaded to the table only the research that was done with English language text. But to put in the perspective, we have 7,000 languages spoken around the world, and the vast majority of so-called natural language processing, so working with different languages, processes apply to 7 key languages. So a lot of algorithms, a lot of information online, a lot of tutorials online you could find for English language, for Chinese language, for Urdu, Farsi, Arabic, French, and Spanish. But what to do if you are from a non-English speaking country, for example, as me? So this is one more challenge for content analysts. How to work in automatic content analysis using non-English language text. Categorization of automatic content analysis software. This software could be categorized into programming languages, and I talked about this, such as R, Python, and different libraries, and tools with graphical user interfaces when programming knowledge is not required. So one of these examples could be webQDA. Tools could be divided into paid and free options. Some tools are created by researchers and freely available as open source for all the research community, while some other are developed by commercial enterprises and used only if you have a license for it. The choice of the tool is dependent on the scholar skills. Okay. Moreover, the use of method, we talk about method, but we don't have time to go deeper to every of these methods, to go inside the methods. So the use of the method depends on the available computer memory also. Due to the lack of the resources, the researchers were forced to choose not so complex methods or solutions. Because we have so much data and it's not possible to use the complex solutions here. But discussing big data issues is not the goal of our seminar today. Let's go to the conclusions. Our research showed that automatic content analysis become more and more popular. However, in many empirical cases studied, automated content analysis is perceived as a mathematical or computer algorithm. And I try to say this now during that seminar. Or the set of procedures that allowed conditionally easy extraction and handling of text. So if the computer algorithms or mathematical techniques are used, so social scholars need to work together in interdisciplinary teams. Scholars solve the task of text classification, segmentation, and clustering, and call this automated content analysis. So this is a problem of language. Social scholars say automated content analysis, mathematicians or data scientists or computer scientists, they say that they classify data, that they segment the data, that they cluster data. But actually, this is some similar tasks. The researchers argue how to identify different type of text and that mathematical solutions and methods could be applicable in a specific situation, including working with social media text, that the text as such are complicated. Let's conclude this, we're out of time. An important step in automated content analysis is a code book preparation. This is again a term from computer scientists, that is borrowed from computer scientists. So that code book preparation means data, text mining, extracting, preprocessing, and preparing a code book for this. While developing a content analysis, it's recommended to create that code book and inside it to put the categories and some determined samples of text that you would like to collect. This is again a bit complicated to understand that if we want to collect unique texts, that's a bit complicated. In automated content analysis, this step that comes from mathematics is replaced with text mining, extracting, and preprocessing procedures. When I started to talk about this, when I started my presentation, I said, but I would like to stress again, automated content analysis is not that objective and valid as the researcher itself. When researchers do a manual analysis, it's better for the result, is more valid than the automatic content analysis that makes a lot of mistakes. And automatic content analysis is context sensitive. Okay, so I'm finishing, but I would like to say about the limitations. So apart from the fact that automated content analysis is very innovative, is rapidly developing, some limitations, but it's very subjective. And it works with social media texts that are trained and applied to some specific situation or context. Natural language processing tools need to be used. And these tools has low accuracy and reliability. So we will need to know these limitations, and we need to think about this when starting automatic content analysis, not a traditional content analysis. And the final thought that if we have some big data samples, this method is very good and it works well. But if we have not so much data, we'll need to think which one of the methods works better for us. Yeah, so I'm a bit longer than we planned, so I stop here. Thank you very much for attending, for listening. For longer online discussions, please reach me on ResearchGate or through webQDA colleagues. And I would like to ask, dear Sonia, do we have time for questions? Or